so there's a couple things I want to talk about. Mainly performance, that's probably why you're here. Simplicity, how that ties in, and show you some practical examples with MiniProfiler, all right? Let's get into it. Step one, you got to care. This is like the main thing. A lot of companies don't prioritize this. If you don't care about it, it's not going to ever get priority. It's tech debt. It builds forever. Your performance will go slower and slower and slower. You'll get bogged down in it, and you never recover. Eventually, you get these systems that no one wants to touch, right? No one wants to own it, because if you touch it, you own it. Everyone knows the rule. But you know what? You're here. You're already along those lines. So this is what I'm talking about with prioritization. Deadline-driven development is the common for everybody, right? It doesn't matter if you're using Agile or Waterfall or test-driven, doesn't matter. Your boss uses this, right? And if you're a boss, you probably use this. This is the reality. People change their priorities, all these kind of things. Sorry, I don't have any of my notes because tech. Simplicity. This is one of the main features that you want to care about when you're building software, okay? When you can simplify things, you can really save a lot of problems down the road, right? If you simplify a thing now, you're not building a complicated thing later, all right? This is like critically important. One of the things we do at Stack Overflow is, you hear it as KISS, right? Keep it stupid simple, or simple stupid, whatever you want to call it. Build it as lightweight as possible and as simple as possible, and it's easier to do everything down the road, right? There's a lot of attributes you get from this, okay? When you're building it, designing it, reviewing it, like it goes through a PR. Anyone here who's reviewed a PR, a big long one is a lot more weight and takes a lot more time. You have to set aside a lot more time. There's a lot more discussion. If something's wrong and you change it, there's a lot more to retest. What if when you pick a part, you can simplify this into 2 little things that ship? This is the basis of Agile, right? You can take little things and ship them a piece at a time, not something big at the end. Now, if you can do simplification early, then this is the kind of benefits you get later on, right? A simple system is just easier in every way imaginable down the road. You spend more time in the spec phase, okay, and less time in the build phase. That's what I'm talking about. I'm not trying to say make up time here. That's not what happens. And this is like the most critical part of this. People start simplifying in methods, right? Developers love a 5-line PR, right? You can optimize the crap out of a 5-line PR. Everyone's like, oh, no, move that, move the greater than. Oh, your date math's backwards. This always happens, right? But people don't want to optimize a 4,000-line PR. They just want to get through it and be done with it. That leads to a system that is not well reviewed, not well maintained. It's harder to ship, right? Just look at the ship cycles on the lines of PRs. It's exponentially more expensive. Doesn't matter if it's open source, closed source. It's all the same, right? But if you simplify things back in the spec phase, we spend a lot of time doing this. My team gets specs from all the different teams at Stack Overflow, and we pick it apart. And we say, do we need this and this to ship at the same time? Can we ship this earlier? Can we disconnect this? Look, this is a different feature. I get that you were thinking about it when you wrote this spec, but these 4 things, the same thing, this 5th one, that doesn't belong here. Let's do that after. And look, we could do 90% of what you wanted in 20% of the time. And you end up with a simpler to maintain piece of software or system in this respect, right? Do these systems need to talk to each other? These are the kind of things you should be questioning back in spec phase. Don't do it when you're in code. You're in code and you're optimizing this little part of a 9,000 step system. Okay, but that's not really going to get you much, right? One of the important concepts with simplicity in general is, do you need to call that API? Do you need to call this cache? Do you need to run this query? Do you need to show this on the page? A lot of times, designs will change. You don't show this on the page anymore, but you're still querying it, these kind of things. If you don't need to do any of that stuff, don't do it. If you do nothing, I guarantee you it will be faster than doing something in code, okay? I'm going to use Stack Overflow as a practical example of this, because this is core to our methodology and how we build, and it can show you the benefits in actual hardware savings and things. So that leads into performance, okay? Also a feature. If you read the abstract, you know this. It's a feature that gets you a ton of benefits down the road, okay? So some of those are you're buying less servers, or buying fewer servers. Sorry, my wife's an editor, she's gonna kill me. When you have a cloud, doesn't matter. You're paying cloud compute. So a cloud company, it's honestly not in their best interest for you to be efficient because they charge you based on usage, right? That's not against cloud companies, it's just a fundamental of economics. When you're buying server hardware, if you're less efficient, you need more servers. If you were calling the database more and weighing it more, you need to spend more database money. If that's on a paid database provider, that's big money, okay? We're on SQL Server, it's not free. If you're doing anything like that, utilization means cost, okay? It also means opportunity cost. So if you're spending your CPU cycles doing this, or spending your developer time trying to go back and do performance optimization, there's other things you're not doing, right? This is all performance cost that you're missing out on. Because you're just wasting away opportunities because look, you're at redline and we gotta solve that now. You design simple, you do performance up front, or just keep an eye on it, okay? And I'm gonna show you how this works. Hopefully we'll get to some numbers at the end that a good friend of mine and I pulled out this morning. So you're also, if you don't have to have as many web servers, okay, you don't need to deploy as many. We deploy to 9 web servers. It goes pretty quick. If we had to deploy to 300, well, what are we doing? Are we doing a complicated system of rotating servers out? Are we deploying to 300 in sequence? God, that's gonna take a while, right? By having performance and simplicity and treating them as features together, the builds are a whole lot faster. We can build Stack Overflow from source to all the way to production in about 10 minutes. Okay, prod's about 5 minutes, meta's about 3, and that's, dev is just CI. So the other concrete benefit, if you're trying to convince a boss, is better user retention, okay? And this matters because users bounce off pages. Do you like slow websites, right? No one does. So when you're looking at it and you're saying, hey, users bounce out and they go faster, what does that translate to? It's not just a cost of a user. You have to spend more on marketing to get more users, right? There's a lot of downstream costs in the fact that you're losing users to performance, okay? There's a lot of studies on this. You can Google around. A lot of people have published things. Companies a lot bigger than ours. Amazon does some really big ones because they sell things. It's really important that their users stick around, right? So I'm going to use Stack Overflow here. Totally random example. I just happened to work there, okay? And this is how we have benefited over the past decade of treating performance as a feature, okay? So these days, it's 8 to 10 billion hits a month on our web tier, and that's on just 9 web servers in production. We run them in a rack in New York normally, and that runs about 10% CPU. And I'll show you a picture if you don't believe me. It runs fine. This is on .NET old framework, so the platform really doesn't matter. You can make anything go fast if you care about it, okay? And the way you do that is pretty simple. We'll get into this. This is the way we deploy Stack Overflow. A lot of people are aware of the public website. You've probably used it. I should probably say it's a Q&A website for programmers like you. If you haven't used it, check it out. They have answers and things. You can see the big one. It gets billions of hits a month. There are 350 sites to Stack Overflow. It's called the Stack Exchange Network. We have cooking and fishing and brewing beer and all these fun things. These different verticals, silos of knowledge. They're multi-tenant, okay? Each one has a database. All of this runs in one app pool per server, okay? You just come in and based on the host address you're coming in on, we pick a database, we pick a style sheet, and we serve up the stuff. But all of this can run on a couple of servers, use a couple of gigs of memory, anywhere between 5 and 10 gig, because GC is lazy, doesn't actually need that much. And it runs pretty fast, okay? That's the servers we just covered. Stack Overflow for Teams, also in the same data center. This is a different way that we're deploying Stack Overflow for private Q&A coming up, okay? And the reason it's interesting from a performance standpoint is the things we've done for the past 10 years, caring, means performance is not something that we're mainly addressing with Teams where we can have thousands or hundreds of thousands of teams on a couple of servers, okay? It's just wins from caring about performance before. So this is actual dollars we're not spending to do this. And in enterprise, we deploy in the cloud. It's all isolated, and each customer gets a thing. If the code's really, really fast, we deploy a small version of it, you literally just don't care about performance. It's done, right? Or sorry, if you cared before, it's so good that a customer going thousands or hundreds of thousands of hits isn't going to make a dent, right? But if you're deploying it, enterprise is currently, most of our tenants are in Azure, right? You pay them dollars to run database queries and use their web servers and eat their CPU and run your VMs. How big of a VM you need, that determines your cost. So at scale, you get more and more customers, that multiplier matters, okay? Scale is all about multiplier. If you if you have good performance here and your costs are lower, that cost times your multiplier can add up really quick, right? Your wins and losses are multiplied by your scale, all right? Whether you're big or small. This is a view of Stack Overflow's client timings. One of the things I want to drill into your head about performance is that it matters what a user feels for things like bounce rate, right? It doesn't matter how fast you render the page. We render web pages, median, I just pulled the numbers this morning, 19 milliseconds to render a page. That's awesome. We're also in a data center that's a long way from Australia. The person loading 400 milliseconds in Australia doesn't care that we rendered it in 19 milliseconds. They care that it loaded in 400, right? This is an area where if we were in the cloud and closer to them, it might actually be net faster, right? We don't know. That's a whole big complicated question. But one thing that's important to remember is don't focus on the little small part of the pipe. If it's a big percentage of a thing you're working on when you're tuning something, great. But keep the big picture in mind, okay? The user is loading a web page in a browser. They're not running your database query, okay? That's just a very small part of the operation that's going on overall. So when you're talking about how do you tune performance, the formula is very, very simple, okay? Find the slowest thing, measure it, okay? 1 and 2 are kind of the same step. Optimize it, measure it again. People forget this, okay? If you're not measuring, you have no clue if you made it faster. You can guess and you can make assumptions. I'm gonna get to MiniProfiler at the end. This is where you can actually see and measure and do things and record it. We record for every single request at Stack Overflow how long it took to render, how many SQL calls we made, how many Redis calls, HTTP calls, Elasticsearch calls, and how long all of them took for every single request. 300 to 500 million a day. We log every single one because we can go back and see what's got good performance, what's got bad performance, where did things go completely off the rails, right? No, we're not on Ruby. This is what it looks like just a normal day, peak traffic, right? The SQL servers are around 6 to 10% CPU, generally, somewhere in the low single digits. And then the web tier runs around 10%, okay? And we haven't optimized in a while. We've actually just been busy with other things. Any kind of tech debt, you accrue it up, right? And then you pay it down. And it comes in waves, right? You have busy seasons, you have slow seasons, you have deadlines. This is deadline-driven development. If you have a deadline, tech debt tends to pile up faster than you burn it down, right? Right now, we've actually accrued more, and you'll see that coming up. So the more you know, okay? This is important to know your data, and this is where measuring is just so critically important, okay? If you're measuring and you're monitoring and you're recording stuff, you can discern a ton of things after the fact. You don't have to spend time debugging it now. The fact that you're measuring it now means you can debug it tremendously later, okay? So the example I'm gonna use is caching. Should we cache an object or a page or something like this, okay? What do you say when someone asks you if you should cache something, right? The only legitimate answer is it depends. You don't know. Is it worth caching? Is it hard to compute? How often would the cache be hit? There's 100 questions you can ask of whether you should do this, right? Record your data, and you'll know. So one of the things that a lot of people will think we do is cache the question page on Stack Overflow. This is just a random question, probably something about Git. These are one of the most common questions, right? How do I fix my detached head? What is a detached head? Why does Git have heads? These are things that are hit lots of times a day. So the cache hit rate would be pretty good. But in reality, we have a lot of questions. So people think we cache the page like this. And we used to. We used to cache it for 60 seconds per question page when it renders, okay? But look at all the dynamic stuff on there. The dates are relative, right? If it's 60 seconds, it would show ask 1 second ago for a full minute and then change, right? People's reputation, people's display names, the content, when it's edited, how do you purge all this stuff? Geez, that's getting complicated pretty fast, right? What do we actually cache on this page? Just these bits in the sidebar. And actually, when I was digging in to some data here with Jason Punyon, good friends at Stack Overflow, it's awesome on our data team. We're actually going to stop caching a lot of these because they're inefficient too. They just don't have the hit ratio you would think. So we cache the HTML for the 2 green sections, and we cache the objects in the yellow sections to render, like which teams you're in, and some of these bits are rendered. We do a random selection, and we print out things, right? But that's it. Everything else is queried live. From SQL, from Redis, all those counts you see in the top bar when you go, all those are fetched real time because it's simpler to do it that way, okay? The simplicity means all that BS you have to do with caching isn't on the table. I don't need to care when to purge it or any of that stuff, right? And the key of this is how much that cache would be effectual, right? This is knowing your data. So if you look at this, this is a graph of Stack Overflow, and on a given day, this is 5 days we graphed here, how often would those questions get hit? And you see the vast majority of questions are beneath here, right? 10 times a day. We have 9 web servers. Even if you cache the page all day, only this little bit of questions would actually ever hit cache, right? And that's if you cache for a whole day. We were caching for 60 seconds, all right? So Jason decided to run a little experiment for this and say, hey, what if we cached indefinitely? What if we had infinite memory and just shoved the page in cache and left it there? You know, just the fact that it's stale, be damned. We don't care. It's just going to cache it for the optimum, like, unicorn scenario of what could you get. So if you look at this, these builds up top are actually the ones on Friday. People say don't deploy on Friday. Damn sure don't deploy on Saturday or Sunday, okay? So these are the 72-hour builds. So they get a chance to actually build up to a nearly 50% cache hit ratio, right, or cache hit rate. Everything else, we build so often that you're flushing the cache out of local memory. Our cache rate, if we did a minute, would be effectively 0. It's like 0.000 something if you run the numbers. It's not worth caching, okay? Even though we run 9 to 10 queries per page, we can hit Redis for a logged in versus anonymous user 0 to 15 times. It's still faster not to cache, okay? So when people say, oh, I'm doing this query when I shouldn't be, measure, okay? The only way we get this is by measuring. So the other big thing is, this goes back to simplicity, okay? If you don't cache, all of the stuff that we talked about with when do you purge it, right? A user gets upvoted, they change their name, rep goes up, rep goes down, comment was added. How many things are dynamic on that page? It just doesn't make sense, okay? If you don't cache it, you eliminate all those problems, and we know caching's half the hard problems in computer science, right? The way we do this, the way this came up, that we deal with at Stack Overflow is MiniProfiler, okay? This goes back to caring, all right? You want to see this on every page load. The way MiniProfiler came about was basically Jeff Atwood said, hey, it would be really cool if we had a number at the corner of the page that told you how long it took. Because he kept telling us this page was slow, this page was slow, this page was slow. And all of these other ones were fast. And of course we said, Jeff, you're full of crap. That's not true. We know they're fast. And so MiniProfiler was born out of one of the best reasons to do anything, right? To prove them wrong. So we already had a MiniProfiler version in chat, right? Mark Gravel had already made in the HTML, just the source, he just printed out a little tree. Because profiling is just two things. What area are you in? How long did it take, right? You just need a description at a time. That's the basis of all profiling. The rest is details, okay? So we already had this printed out in chat for like how long the database was taking, load the user, these kind of things. MiniProfiler is the productionized version of this, okay? Installing it is really easy. It's just a NuGet package. You put it in. There are docs on miniprofiler.com that show you what to put in your startup file, like any ASP.NET Core app or ASP app. If you have problems, file an issue. If you don't know, ping me on Twitter. I'll put that at the end. I maintain MiniProfiler these days, originally built by Sam Safran and Mark Gravel and Jared Dixon. But it's pretty easy. So configuring it, this is the ASP.NET Core version. We're actually not there yet. We're moving Stack Overflow now, but some of our stuff is ported. It's pretty simple. You can pass some options. You set up, and you use this in middleware. And the way ASP.NET Core works is it calls middleware to middleware to middleware, and then eventually you render your page, right? In that middleware, when we start it and it handles these other things and comes back, it's profiling that whole loop. So whenever you do things inside of it, it's just handling it for you, right? You set up some options of, do I profile, who can see it, where do you store it, how do you format the SQL, but it handles the rest, right? And then in the page, you just put a little tag right here, and it renders the JavaScript to render it. So we show you what it actually looks like, right? The other big piece of this most people want is your database queries, right? ADO.NET uses something called DB connection, which is an abstract base class. We just wrap it. So we just intercept the calls, wrap them with a stopwatch, and call them. It's really not a complicated process. You're free to look at the code. It's MIT. You're free to steal the code. The main effect, though, is what does it look like, right? So this is the question show page, all right? Now, I said it was 19 milliseconds on average when we render. Mine's higher. I'm not lying. I can show you the data. I'm a moderator. These things like flags over here, these are extra queries, okay? Most users don't run this stuff. But the important thing is, see that number? It's on every single page, every developer on Stack Overflow sees, every time we render it. What's another secret to that is that it's on every page you see, you just don't see the number. We record all of them, and we only store the last in like bad ones, right? The top 10, the top 100 slowest is what we store. So we can go back and see, man, what did this person hit? What was stalling? What kind of lock did they see? That kind of stuff, right? So when you click it, it gives you a breakdown of what you had in the page. And importantly, remember I said the person in Australia getting that very slow page, what did they see? And we don't actually use this functionality, sorry. But you can send these profile timings back up to the server to see what the clients actually saw from a holistic view, not just what you rendered. Because what you rendered is hopefully a small part of that, right? And inside a company, the transmission time may be near zero if you're in a LAN, that kind of thing, right? You're not seeing a lot of steps here because it by default collapses the, we quote, trivial things. You can set a threshold, what is trivial. It defaults to 0.1 milliseconds, I think, or 0.2. If you actually expand it, there's a lot of stuff that happens to the page. You can see the scroll bar there and see how much happens in a normal Stack Overflow page, right? It's a lot of stuff. Still not efficient to cache it, okay? Look at measure. Measure is your big thing here, okay? And in those, when you see these columns on the right, these are the SQL and Redis and timings and things, you can put custom ones, then you see all that printed out. This is the query that fetched my comments, right? So even though this query looks complex, we're on this query one for logged in users, because we need your votes, right? Did you flag a comment? Did you upvote a comment? We need to highlight that. The query is slightly different than anonymous users. And we run those between 6 and 29,000 times a minute. And it's fine. It's very, very fast. I'll show you that. So in MiniProfiler, when you're clicking in the page, you can quickly see this. And I can copy paste this and go put it in my database editor, right? Or SSMS or whatever query tool you're using and go query. And it's a very easy way to go back and forth and see what's slow in your application. And you see on the left-hand side here, all of your commands, it says when it started and how long it took. So you can say, oh, this only took 1 millisecond, I don't care. Or this took a long time and it started up front, that delayed the rest of the page. Things like this, right? That can matter for various reasons. This is what I'm talking about with the comment piece right there. See, the top question, or the top query on this is running 33,000 times a minute. That's just fetching a question every single time. We always fetch from the database directly, right? It's not particularly efficient from one point of view to run it this much, but it's so simple that it's fine, okay? So if you look at that top query, it's running in 41 microseconds as an average. That's nothing. That's fine. And the SQL Server you just saw was at 0 to 10% CPU. It's a great way to optimize, right? But MiniProfiler helps us keep an eye on this, all right? If that query does start going slow, we can load the page immediately and start seeing and dig in, right? It's also a good debug tool. If you're like, hey, dev, look at this query. They don't need to go dig through the code to find the query. You can just say, this page does this. They can go hit it, load MiniProfiler, and then copy the query. Like see how an outer apply works in SQL, these kind of things. And this is just showing how often that query runs for comments. And you see that the bottom part's slightly different. This is for an anonymous user, because it was the first one I clicked. I messed up the slide. So examples of how to use this, okay? If you're in .NET, it works with anything, right? F#, C#, VB, whatever you care to do. So when you're doing, this is just an example of where you can wrap it. We use something called step here to just have a very quick, it allocates a string, but it very quickly tells you where you are. This is something called call or member attributes in C#. You can use these anywhere, and the compiler actually puts these in, what method called it, and what page and line number it was on, okay? And if you actually go back to the query that was on the page here, you see that little gray text up top? We see that in SQL too. So we put in our SQL queries where it came from. So when the DBA sees that there's a problem, we know where to find it in the app. Very small trick, very, very efficient way to do software and debugging. Simplicity, right? So there's a very, very simple way to debug things. This is an example of using it to wrap a database query, okay? This is just, hey, this is a method that gets the total count for your inbox at the top of the page. We actually cache this in Redis, but, the count is incremented in Redis. But for like a new user, when we send an email, we have a method. So this is just run a SQL query. It's very, very simple. You're just wrapping it in this using here, okay? And you can call the step whatever you want. It's made to be simple. It's made to be mini. It doesn't profile every method. That's expensive, right? When you're profiling every method call, there's a warning when you have a profiler, right? And it says, hey, this is going to be really slow. Are you sure? We don't do that. It's mini for a reason. And this is just another example of showing startup timings. There's another common use case, right? And your app is slow to start up. It takes 10, 20 seconds to cache all that in memory. Just fire up a profiler, use it to profile around these things, and then stash it somewhere, okay? The MiniProfiler help in our case, that's just a static field. That's all it is. And there's a dev page that shows it. That's it. So when we go to a server, we can see what took so long to start up, right? Very, very simple approach. So this is what's included in MiniProfiler by default. Of course, it's fully extensible. You can build whatever you want. But there's helpers for ADO.NET, right? That SQL connection wrapper you saw. Entity Framework Core, these are all covered. And MVC, like profiling your actions and views, this is all built in. It's all NuGet packages, grab it and go, okay? And for storage, wherever you want to save your profilers when you're done, this is all built in as well, okay? It's called async storage. You can implement it as whatever you want. You can have it email an intern to save it if you want. Any kind of memory is the default, and it keeps it for half an hour. but however you would prefer to, if you have an existing storage mechanism or database or data store or shared cache, you can use that stuff. We don't have blob storage or anything like that. Some people use it in the cloud. If you want to contribute it, happy to have it in the repo. So this is what I wanted to hopefully have time for. We did some digging when we were doing this talk. And one of the things we looked at is the perf had regressed in Stack Overflow, okay? So when we were looking at numbers, this is where I said record. Record everything and you can go back and look at it, okay? I haven't had time to look at these numbers in about a year. And it turns out they've gotten worse, okay? So let's look at this slide. If you look at 450 to 480 days ago, there's nothing special about this. I just picked a 30-day range a long time ago, okay? We were at 32 milliseconds total. And by total, I mean from the load balancer to the web server and back. This was total render time inside of our infrastructure, okay? We've slowly digressed down to 46, all right? Now the .NET time is from application begin request to end request in .NET, inside of ASP.NET MVC, right? So when you're in that area, we're capturing the total time we know about. Now importantly, look at the two columns there. The first column increased by 14 milliseconds, right? But the second column only increased by 8. Uh-oh, where'd our time go? We've got stalls that we can't explain. They're happening outside of what we monitor. But because we captured this to the load balancer, an external point of view, this is also important in monitoring, right? Get what your clients see. Get what your load balancer sees. Get something outside. Don't trust yourself when you're monitoring. Get a sanity check. And that's what this is. So TUR tells us these things. We're stuck in the IIS pipe, or we're stuck behind garbage collection, or we're stuck behind some sort of crazy locking built into Windows, right? Maybe we're socket exhaustion. Who knows? All we know is we know what time we could see and that the external sees, and there's a gap there, okay? That gap is telling. So you can see there's also Redis here has gone up by a millisecond. I have no clue why. When I get home, I'm gonna have to go figure that out, right? It's gone up the past month. I have no clue. It's not enough to pop out on a radar for monitoring for us, but we have this data and we have per request data to go see this, okay? And this comes from MiniProfiler under the covers, okay? So all those things you saw in the MiniProfiler pop-up that's like Redis, SQL, and those things you can click and see the commands, those are what feed into these numbers in our load balancer logs. We simply append the count and the total duration as headers out to our load balancer, and then we stick them in syslog, and they go into where we restore HTTP requests. And there we get these columns in SQL. I was able to pull these numbers in about 2 minutes from querying SQL, right? Took me longer to write the query than to run it. You see SQL increased by 0.7, right? Redis increased by 1, and HTTP increased by about 0.3. So about 2 milliseconds we know went to calling stuff on the network. But we still have another 6 here in .NET that we don't know about, okay? So then we get into, did it really go up, okay? Don't trust averages when you're looking at perf. Don't trust averages actually anywhere for any statistics ever, right? And don't use a pie chart. They didn't even like me to say that. So when you have the median time for today, I just pulled the numbers for actually for yesterday, this morning, right? It's 19 milliseconds. So it actually hasn't gone up that much. But you get in the upper percentiles, right? Oh, we've got some outliers. That's what's throwing our averages way, way off, right? And even the 99th percentile is only 68. So we're probably, for it to pull the average that much out of millions and millions or hundreds of millions of hits, it's got to be really up there. So our 99.9th percentile's got to be skyrocketed, right? So Jason and I this morning hopped on a Hangout, and we looked at these numbers, because it's fun. Why not, right? This is hard to see. I'm sorry. So I tried to highlight it. This is all the hits per minute to Stack Overflow for like a 30-minute period this morning, okay? So this is the ones that took 4 milliseconds, 5 milliseconds. The specifics don't matter, but you see the medians are around that 19 millisecond range, okay? There's a difference between logged in and logged out. Logged in users have more data, right? We need to fetch more things. Your counts from Redis, the top bar. That's why those logged in boxes, the blue ones, the teal ones, are a little bit higher. But the main thing here is occasionally, randomly, look at that giant spike up there. That's pulling our averages way off. That's the reason that our average is so much higher, okay? And because we recorded every single row of data for this, or some sampling when you're recording, we can determine this, that something went way, way, way off the rails here, right? There's a lot of things that could do this when you're looking at a production application. When you think of something at scale, think of it as a highway, right? Something like a freeway with 16 or 100 lanes, right? Let's take an example of the SQL Server or MySQL, Postgres, whatever you have, is a MongoDB. I don't want to be, Any NoSQL is also welcome here. If you have so many lanes, connections, this applies to sockets, HTTP connections, RDBMS database connections. You have a connection pool often, right? That pool has so many entries. If they're all backed up and waiting, then the 101st, say you have a 100 pool, right? The 101st one's waiting behind that, okay? So if there's something stalled, you see a freeway, you know what happens when a car wrecks, right? This is basically what happens with any pipeline system, okay? Cars going fast and speeding through don't do anything. They really go on. I had a professor at State that had a demo of this, of like a freeway flowing and fast cars going by and not causing any issues, and then some slow cars going, and things just went sideways really quickly. I really wish I could find it because it was the best demo ever, because it really applies to computer science in every pipeline way, from internet to database, doesn't really matter. When you pile up these things and you start overflowing these bottleneck points, these like limits, right? Things just pile up like crazy. Stack Overflow is very, very efficient because we are fast, okay? That's good and bad. If we are slow, we die. We go offline because we will exhaust that 100 connection pool like that. Each web server is handling 300 to 500 requests per second. If a query stalls for a second, we're out of connection pools, right? Well, our connection pool is overflowing in 1/5 of a second. That's a quick death, right? And once you go over that and you start piling up, you don't get out of it. You have to like relieve pressure or cut off that web server or do something to this, right? And these are the kind of effects you see. For a minute here, this one actually recovered, so it was not that bad. But if these stalls had persisted for another minute or two, we'd have seen some alarms go off, okay? So this is like just under the radar of being bad. So when we looked into it, one of the obvious things to look at for .NET especially is the connection pools. Are you piling up against that? Are you piling up against a lock, right? So a critical section of code is a term in C# or the .NET platform in general. You have a lock, right? Anything inside the lock's critical section. You pile up, you're waiting. And that can manifest not just in locks in code, but like anything that's a locking mechanism, right? Atomic lock against Redis, mutex against SQL, anything like this is something that you wait against, and everyone behind you starts piling up. In our case, for .NET specifically, if it helps, thread pool is something you can die of exhaustion really quickly, okay? So when you have a thread pool, it grows by, I think, a thread every half second or a second. It doesn't really matter, because when you have multiple hundreds of requests per second coming in, neither one's going to help you. You're going to fall over and die pretty quick. So your connection pool, let's go through, a query goes slow, okay? Stack Overflow, you load it, and the comment query that I showed earlier suddenly takes 3 times longer, okay? That's all it takes. It takes 3 times longer, connection pools start piling up because the amount of time each person's querying it is longer. So that 100 where cars are flying by, each car, if you were to look at a line, goes a little bit slower by, right? And eventually you run out of that 100, and that starts falling over. So then you have pages and threads waiting behind that query, and then you start to exhaust your thread pool, okay? So then when your thread pool goes over, you've got anything from you can't get the page, the server's unresponsive, all these things start to happen, right? When the thread pool falls over, IIS actually uses the thread when it pulls a new connection in, so it can't issue requests. So now sockets are overflowing, and buffers are overflowing, and your network card fills up. And basically, it's your train wreck, right? It's like a freeway crash, and every single side road is now packed in. This is what happens, okay? So being efficient is good in one way, but only if you stay that way. But this is why it's so critical that we measure. And this is where MiniProfiler is like a way for you to do that, to just keep an eye on these timings. If you can record them somewhere in aggregate, even better. If people have better ideas of how to do this and open source this, great. We store them in SQL Server in a massive database. I don't think that's a good open source solution, right? If you've got ideas for that, hit me. We could put them wherever, right? This is just some information for, sorry, I went through that a little quick. This is thing where you can find more information on each of these things, right? MiniProfiler.com, it's not just for .NET, by the way. It's in Ruby, it's in Go, it's in Java. Communities maintain these things. Node, I mentioned. Node's pretty actively maintained, and Ruby's pretty actively maintained. Sam Safran puts a lot of work, perf work into, also a good follow on Twitter, for Ruby and Rails in general, works at Discourse. My blog, I talk about our infrastructure, how we monitor, how we deploy, how we do these things. If any of it's useful for you, we're wide open. You can ask me about anything if we haven't blogged about it. It's not because we don't talk about it. It's because there are limited hours in the day. I wish I could get 30 more, but it is what it is. I tweet about this stuff as we debug it all the time. If you want to see the numbers I showed you, the regressions, follow me this week. Or just query and watch along, and you'll see we'll be seeing what that GC stall issue is. We're going to work with the .NET team on some of that. There's other stuff we do to help some of this stuff though, like Dapper. You saw in the how we run against database queries. If you haven't used Dapper, it's lets you write raw SQL and get back C# objects in a very, very lightweight way. These are things we built to help solve a problem when we built Stack Overflow. They're not what we call a core competency, right? They don't help us. They're not a trade secret or anything, so we open source them. How we connect to Redis, Stack Exchange Redis, these kind of things are all perf boosters. We take a lot of effort to test them and scale them at SO and solve some of the scale problems, and you can just absorb for free, those kind of things. And if you're curious more about the performance, I need to go update the numbers a little bit. They're out of date by about a year, but you can see how the other stuff we do, WebSockets, and what the utilization of Redis and SQL and the web tier, these kind of things are at Stack Exchange/performance. It's a page we just put a long time ago. And if people have questions, you're welcome to come up after. Obviously, I've built Q&A for about a decade now, so we like it pretty good. And that's it.